welcome to this session. My name is Derek Yang. I'm the tech hardware analyst at Morgan Stanley. So in this session, we will host Solomon. I think the company name certainly came under the spotlight after the company logo specifically showed up in Jensen Huang's presentation during GTC in March. So today it's an honor to have Chairman Johnny Chen and CFO Jack with us to discuss their company strategy regarding what they are doing right now, what they plan to do in the future. So without further ado, let me pass it to Johnny for his presentation.
Good afternoon, everyone. My name is Johnny Chen. I'm a chairman of Solomon Technology. In my previous life, before 2009, I was an analyst for Deutsche Bank covering semiconductor industry, TSMC, UMC, and later on I was the head of research at BNP Paribas, Taiwan. So it's an honor to have this opportunity to introduce my company to you. So you may be wondering why I transition from investment bank to Solomon. Solomon is a company that started by my father about 50 years ago. So I came back to this firm 2009, and since around 2013 we've been working on robotics and later on AI. So today I will be talking about our applications in AI and how we got into this field. So these are just disclaimer. So Solomon was founded in 1973. It's headquartered here in Taipei. So we have four main primary businesses. The older lines of business is our energy business, gensets, generators. We are distributors for Cummins engine for diesel gensets, as well as for GE Yanmar. GE later divested this part of their business to a private equity company. The second part of our business is LCD manufacturing, which is over here. We have a couple manufacturing plants, small plants in Kaohsiung and Dongguan, China. And the third part of our business is automation. And this is where we got into, that got us started into robotics and AI. And the final part, the latest, is our AI robotics. So these are just some of our office locations and our distributor or SI partners' geographic presence. So until 2010, we been primarily involved in very traditional lines of business. As I mentioned, generators, LCD manufacturing, semi-component distribution, which we divested back in 2007. It was 2010, that's when we started to get into automation. At the time, we had the opportunity to become the distributor for Rockwell Automation, the largest PLC and drives a lot of industrial control products, largest maker in the United States. So we became the distributor for Rockwell Automation in 2010. And around 2013, we tried to expand a little bit outside of industrial control. And that's why that was when we thought about robotics. At the time, when we approached a lot of Japanese robotics companies, none of them wanted to deal with us because they thought we didn't understand anything about robots. So it was very interesting that I was traveling in Europe at an automation exhibition, and I met with the CEO of this robot here. At the time, this company was not very well known. It was called Universal Robots, which today is the largest collaborative robot maker in the world. The difference between robot and cobot. Robot, you need to have a cage surrounding it because it's moving at very high speed. So if there's a worker next to it, and the robot hit the person, that's going to be a very serious safety issue. with a cobot, it can work safely next to human workers on the production line, and hence the name collaborative robot. And this Danish company, Universal Robots, was the first one to bring out such a concept. And we were the first company bringing cobot into Taiwan. And that's how we got started in robotics, okay? But after we started to distribute Universal Robots product, we figured, hey, this thing can just, if you tell it to go to point A, it was just going to point A, going to point B, it will go to point B. There's very little intelligence to it. So around 2015, we started thinking maybe we should do something else that's a little bit more innovative. So we thought about vision, computer vision, machine vision. At the time, 2D vision was quite, was a lot of people were doing 2D vision. So we decided to jump into 3D vision right away. We thought that would give the cobot or robot the eyes. If you think about robot being an arm, we would provide the eyes to the arm, but that wasn't enough, because if you only have eyes, you can see it, but you really cannot think or distinguish a lot of difficult patterns or a lot of different defects and things like that. So around 2018, we started to get into AI research, deep learning, and using that to help to augment the 3D vision that we already had. So this combination of technologies started to become more useful for a wide variety of applications, some of which I'll introduce later. Okay, and it was 2022. That's when ChatGPT, Gen AI started to become very popular, and so we added Gen AI to what we were offering as well. So, in essence, the AI that's becoming part of our products has also become smarter. Okay, these are just some of the awards we have won. So in terms of our customers, over the years, we have quite a few international customers using our solutions, whether this is for robotics, robotics vision, or for defect inspection, or for other different products, which I'll be talking about shortly. We have quite a few famous customers in US and in Europe, including 3M, Dell, Facebook, or Meta, as well as Applied Materials, Supermicro, all those names. Here in closer to home in Asia, we have quite a few Japanese customers as well, including Toyota, and some Korean customers as well. So the essence of our product, what we try to do when we're talking about Solomon AI, is we try to allow customers to build customized AI rapidly, with ease. What do I mean by that? A lot of the AI out there today is pre-trained, based on pre-trained model. So in factories or in a lot of retail situation or in a different type of environment, you try to have your own customized AI. And sometimes you take a lot of those pre-trained models and try to fit in. It doesn't really fit. The other approach a lot of people are taking is using, they will hire some engineers. And those engineers will take, for example, some open source models like YOLO, you only look once, YOLO for computer vision models, and try to build an application based on that. And quite frequently, that doesn't work as well as they thought. I've talked to many companies. They say they thought it's quite simple. They just hire some engineers, use some open source, and then they figured this will work well for their production line. That's not always true. And so what we try to do is offer a platform where customers can use a very sophisticated AI models that is fairly optimized. We don't just take open source and use it without any adaptation. There's a lot of optimization going on in the neural networks. And also sometimes it's very important to assemble various neural networks, not just one. You got to combine quite a few different neural network models. And what that does is give you a lot of adaptability for a wide variety of applications. Okay, so that's where I'm showing in the lower left-hand corner. We have spent a lot of time on software optimization. Okay, and that's the reason why we can be involved with so many different customers from different industries using the same set of software. We don't need to change the parameters for each project we are involved in. It's the same set of software for semiconductor or for example, chicken eggs quality inspection. The second thing that's very important to make this platform quite easy to deploy is we have to support a lot of different hardwares. And so the software, our platform has to be seamlessly integrated with all the different hardwares. And that includes robots. I believe our software now supports 25 different brands of robots. Cameras, both 2D and 3D cameras. We support all type of cameras. Line scan, area scan, IP cameras, all sorts of different cameras. PLCs, which are very important for industrial settings. AMRs, the AGVs, as well as the drones. Okay. The reason we have to support so many different hardware is because software alone is not enough when it comes to implementation in factory setting. So having the platform fully integrated with a lot of different hardwares gives our customers a lot of flexibility and make it much faster for them to implement a customized solution. Okay, so and one more thing, it's very important. This is a no-code platform. That means the customer doesn't have to spend any time writing code at all. Okay, so imagine it's like a Lego. You're building blocks. You can just drag and drop a lot of different blocks and quickly form a customized solution for any application, vision application you want to have at your factory. So what can this platform do? We'll just show some examples. On the upper right, you'll see a robot here. So some of the robotic applications, pick and place, material handling, like the complex ones like bin picking, depalletizing, kitting, packing. And some of them may not have to do with the pick and place. For example, things like welding, polishing, grinding, things like that. But it doesn't have to be with the robot, have to do anything with robotics. Some of the things in automation lines are better than without robotics, without robots. So here, we can also enable applications like defect inspections. So we did quite a bit of defect inspections for a wide variety of industries. And you can also do classification, OCR, pattern recognition, measurement together with AOI, which stands for Automated Optical Inspection. Okay. And the latest we have developed is something that we combine AI with AR, augmented reality. So this can be used for a lot of different applications like surveillance, counting, SOP validation. SOP is standard operating procedure. So you want to use a camera to make sure frontline workers are doing things according to SOP. Time study, classification, so forth. So I'll be talking briefly about these 4 main products using some real case studies. Okay, this is just it just reinforces what I said. Our software in the middle, it has to support a wide variety of 3D cameras. 20, I believe this has more than 25 now. 25 different brands of robots and cobots, and all 4 different major PLC brands as well. So this is a case in Singapore in one of the world's largest third-party logistics company called DB Schenker. So if you saw a camera, that was a very cheap, low-cost camera, which is using Microsoft Kinect. So what they're doing is DB Schenker takes a lot of items for their customers. In this case, the customer is a Swarovski, the crystal maker. So their boxes come in different shapes and sizes. So without much of a training, we're able to help DB Schenker to do robotic picking with minimal amount of training using a very low-cost camera to do this. And this is the kind of application you can see quite often in warehouses, in logistics centers. This is picking of pacifiers, the baby pacifiers. This is for one of the largest Japanese baby product company called Pigeon. So during the COVID, they don't want to have anybody touching this product. So they decided to have robots picking these items, randomly placed in a bin. And the challenge here is because the head of a pacifier is transparent, so that's quite difficult for 3D vision to see. So we have to add AI into this. So it not only picks individual pieces up, it will also know the orientation and always let it facing down, and do so in a pretty fast pace. I think per hour they need to have 900 pieces picked. And then there's a second station where each piece goes into another machine for work. Initially, the end user tried to use the 3D vision from the robot maker, but it didn't work. So they came to us. The robot is Fanuc robot. So this is for a project in Europe, in Belgium, for the world's second largest contact lens maker, Alcon. We were doing kitting for the surgery pack for eye doctors. Okay, so the challenge here is they have more than 500 SKUs, and each SKU will be like this. So there are 500 of them, and each one of them will be placed randomly in the bin, and the robot are supposed to pick them out of the bin according to their warehouse management system or production management system. And the challenge here was when they were asking for a lot of European 3D vision players, saying, how long does it take you to train to recognize each item? Some our European peers were saying it's not possible. Some of them were saying we need 2 to 3 days to build an AI model for each SKU, which can reach probably around 90% successful picking rate. But the client's next question was, well, are you going to do the training, or am I going to do the training? And some of them were telling the customer, you have to train your AI model to recognize these items. And the customer just walked away, because you can imagine if there are 500 different SKUs, you have to train each one using 2 days. That's a lot of time. So, and that's why they approached us. And it turned out we were using, on average, around 2 hours to be able to train recognition of each item, and allowing the robot to pick at around 95, on average, 95% success rate. And so this is a project in Belgium, but they're also looking to implement a similar project in the United States headquarters. And this we showed last week at the Taipei Automation Show, and it's actually a lot faster than this now. This is the world's first 2 robot. In fact, it can be more than 2. You can have 3 or 4 simultaneously go into a bin and have them picking pieces randomly placed inside a bin. And the challenge here is, of course, how do you make sure these robots don't bump into each other while they're doing all the picking? And this is important because in some logistics applications, you need very high speed picking, and sometimes with only one robot, there's only so much you can process per hour. With 2 robots, you can increase the throughput by roughly around 50 to 60%. Okay, so this is an application in Taiwan Toyota. So basically, they were having a lot of people doing the gluing, spraying, using before using humans, but they wanted to implement this using robot. So you can see there are 4 cobots down there. But the problem is this yellow frame that's holding the car body, it doesn't come to the same stop every time. It looks quite steady, but every time it stops, it can deviate by 5 to 10 centimeters. So they asked us if we could use computer vision, 3D vision, to know exactly where this car body is, and then guide the robot to do the gluing. Okay, so you can see, but of course the challenge is you also got to, some people have to scan the whole car body, but as you can see, we just need to scan the back end of this car. You will see this light coming out. This is a structural light. So once we have this image captured, we know where this car body is exactly located, and then we can guide this robot to start to do the gluing. Okay, so this, I believe, now we are on the 4th unit implementation for Toyota. So that's about robotics. I'll talk about something that's not related to robotics. Okay, so defect inspection is a very important application. And if anything, there's probably more people looking for defect inspection than robotics vision these days. So big industry in Taiwan, semiconductor. So we've done quite a bit of wafer inspection. You can see there is a very light scratch here. It's not very visible. This is quite hard, actually, from a computer vision standpoint. We have a major competitor in North America who tries to use this using a lot of images, sample images to train an AI model, but it doesn't work. For us, for this particular case, we only use 150 images to train a model that can recognize about 99% accuracy rate. This is trying to count the number of, I think this is the storage, the memory. So let me see. Sorry. Sorry, it should be. 怎么放出来？你帮我放一下。那个右边那个。Okay, so the 30, the number 30 I highlighted here is we only use 30 image samples to train a model. Again, a lot of times the customers don't want to use a lot of sample to train a model, you know? And every customer's requirement is different. So if you were to tell them, I need, thousands of images to train a model, most of the time, customers just say, well, that's just too much. I have so many things I have to inspect. So how to make this very efficient process, a very efficient process, very easy for them is a key. Okay, huh? And I can tell them. Sorry, there's actually a video here, so I wanted to show the video on the right hand side, but this doesn't seem to work. Anyway, so this is automotive textile. You can see the two. If you look at them by eyes, it's very hard to tell which is which. But here, using only 13 samples each, we are able to detect the difference between these two very similar looking textile pieces. And we are constantly dealing with this type of project, and we have to make it very quick. Sometimes the customer asks if you can test this type of sample for us. We have to be able to come up with this result within a day or two. And this is contact lenses. In contact lenses, some of you may know that in contact lenses manufacturing, they have a lot of people doing inspection. They already have this kind of optical inspection in the past. It's called AOI, automated optical inspection. But our problem with the automated optical inspection, AOI, is that it's rule-based. So sometimes if the defect is in a very irregular pattern, it has the tendency to overkill. That means treating a good object as a defect. That means, of course, you know, if you don't run the inspection again, having manual labor to re-inspect again, you're going to be wasting a lot of those contact lenses. So with our AI, which a lot of them use, I think 3-4 major contact lens makers in Taiwan are already using our AI to reduce the overkills of their AOI systems. You know? So this is important because I think in general there's about 6-7% of overkill. By using our AI, they were able to reduce the overkill down to about 1%, and that really saves a lot of money and also reduce the number of labors required for re-inspection. This is chicken nuggets. Okay, so as you can see, there are various type of defects associated with this chicken nugget. And these things are running, sorry, again, the video doesn't, okay, yeah, so it's running about 18 centimeters per second. So it has to be able to detect a defect that fast. And once the defect are identified, there needs to be a robot down at the conveyor and picking out the bad pieces. So this was also quite interesting. Again, all this different application you are seeing for defect inspection is using the same piece of software. We don't need to adjust any parameters for each different project, you know, whether it's semiconductor or chicken nuggets. Not sure what this is. This one. To the payphone. Yeah, this is just an example, but we do have some customers asking us to inspect server board, AI server board. You know, they want to make sure the configurations are according to the customer's orders. So we are using a robot to move around the board. This is not a server board, this is just a small board, but we've done this for one of the large EMS, a couple large EMS companies here in Taiwan. And even if you shift the position of a board, it can automatically adjust for the robot's route. So it still be able to inspect the right locations on the board. Okay, last item. After doing a lot of this automation stuff, we thought it was interesting to combine our AI with a lot of different type of hardware. So we decided to try AR glasses, IP cam, phones, tablets, drones, and AMRs. And so, in particular for AR glasses, we have to combine AR and AI. So that generated a lot of new different applications. And IP cams are really everywhere. So before, IP cams were doing mostly very monotonous, very simple tasks like facial recognition or car license inspection. But when it comes to very customized setting and looking at patterns, for example, or machine settings in your factories, the IP cams couldn't do it. So we decided to give it a try, and we added our AI with a lot of cameras from local IP camera makers. And it turns out they could do a lot of interesting stuff using the very low-cost IP cameras. So this is an example. It's a drone with a camera looking at the wind turbine and to see if there's any missing components there or anything that needs to be maintained or repaired there, including any defective welding. To pay phones one. Okay, so this is at one of the largest petrochemical companies in southern Taiwan. So someone in the screen, someone in video is wearing AR glasses, and they are checking if the wheels are parked in the right position. So you may be wondering if humans can see this, why do they need this type of things? Yeah, they can see it, but sometimes they just they don't record it correctly, or things like this, whether they have the cables, the wires are correctly connected. A lot of times the manual inspector simply miss this kind of things. And another thing nice about it is once they detect a lot of us using AIs coming back to their AR glasses, they will know immediately if this is correct or not. And this can be digitized instantly using this system as well. This is one of the largest motor EV electric vehicle motor company in Taiwan. Before, they would have people putting these motors in the spot, and the person has to walk around this to make sure that everything is fine, including if there's any missing component, there's any defect on this motor. So you can see now they have 7 different IP cameras around it. And using our AI to train the model, it took them only about 2 days to train all different type of things they need to check. So the result was, before they had to spend 8 minutes per motor just to check. Now they only need to spend 15 seconds. So that's a 32% increase in productivity. This is just, they want to make sure people are really spending time assembling the pieces. This is sort of the time study, For some reason, a lot of companies are interested in looking at how much time their workers on the assembly line are really spending time assembling product. This one has nothing to do with manufacturing. This is in one of Asia's top international airport. They want to make sure, again, this is also time study. They need to make sure that the air bridge connection is good. How long does it take for baggage handling, refill, and also catering replenishment? Yeah, so they had to time a lot of this to measure, probably for the airport to know how much they want to charge to the airlines. And this one is very interesting. This is with one of the chain pet shop here in Taiwan. There's a lot of turnover in those chain stores, right? So they want to have this AI, so it doesn't matter how long this store clerk is with this company, they will know immediately when a customer brings a dog. They know what breed this is and how big it is, so they know the AI system can tell them instantly what's the kind of product or services they can provide to these customers. So as you can see, when you are connected to a wide variety of devices like IP cam and phones, a lot of different applications you can combine together. So that's very quickly introduction of our products, applications, and please let me know if you have any more questions. Thank you.
Okay, thanks Johnny for the great presentation. So before we open up the Q&A to the floor, maybe the first one from me is that it seems that the competitiveness of Solomon comes from the efficiency that you are training the machine vision model to, for that to adapt to different applications and different verticals. Could you share with us a little bit more about how you could achieve this, or what's the secret recipe behind this dark technology?
Well, this one of the slides I mentioned about where we talk about this as a no-code application development platform. One of the things I mentioned is that the models are extremely optimized, and we combine a lot of different models to achieve very high efficiency in recognizing different types of patterns. So one of the things that we have been able to do so far that I haven't seen anybody doing out there is something called one-shot learning. And we actually demonstrated this during exhibition. Is with one image of each new item, the robot can understand and distinguish the item from any other items. So this is very important for example, where you have a lot of SKUs. Each item is different. If you train each item taking a lot of time, it's going to be a very inefficient process. So able to learn from very few samples and be able to come up with a very highly accurate model, that's something that we have been working on for a long time.
Okay, thank you, Johnny. So now we will open up the Q&A session. If you would like to ask a question, please raise your hand and we'll have the microphone to you. Thank you.
Can you explain what's your revenue model? How do you sell your software? Is it a subscription or is it a one-time?
Okay, yeah, sure. Here in Asia, most customers are still want to buy it outright rather than doing a subscription model. But in US and Europe, subscription is picking up in terms of our products, how we sell our product to customers. It also depends on which particular products we're talking about. The AI plus AR product using non-manufacturing setting, like for retail. A lot of those customers will be asking for a SaaS subscription model as well. So it really depends. But right now, as of now, bulk of our customers here in Asia, they will still buy the product outright. So it's not as full SaaS model yet, although we do support that model.
And one more question on the robotics side. Do you need to know the form factor of the robot? Do you need to know the specific type of robots being used? Can your software be used and then independent of what the form factor of the robot is?
Well, it supports not just a particular robot brand. It supports the different models within each brand as well. But I guess what you're asking is if you are using a different robot and different models, how does it work? How does the software work? So
software and there's a firmware and every robot operating system. I don't think operating system is standardized, right?
No. For this, some of these robot guys, especially the Japanese robot guys, they try not to open a lot of stuff. Some are more open than the others, but some are really closed systems. So for applications like bin picking, that's less of an issue. But for some like a gluing, grinding, polishing, where you have to send a series of commands to a robot for robot to process simultaneously, having access to the robot controller is indeed more important. And for those type of applications, our solutions works better with some of the more open robot types. Here, I can tell you it's Universal Robot, Yaskawa, Kawasaki, ABB, KUKA, but some of the more well-known ones are more closed system. It's a bit challenging to try to stick with them for all the applications. For picking, it's less of an issue, but for some, it could be a little bit more problematic.
Do you have traction in China? Do you sell in China? Do you have traction in China? Do you sell in China?
Yeah, we do have customers in China, and we also work with quite a few Chinese robot makers as well.
Thanks a lot for that presentation, Johnny. Just wondering, how many people do you have in your robot vision software R&D department? And also, are you guys currently engaged with any humanoid developers?
Yeah, those are good questions. We have, for software developer, we have around 100 software developers. We don't really separate them into robot or non-robot. Some of them, of course, spend more time on robotics, but the AI part is common, whether we're talking about robotics applications or non-robotics application. As far as what's the second question?
Are you guys engaged with any?
Oh yeah. We're working with a couple of them right now. Yeah.
I guess as you think about your key points of differentiation, you talked about a lot of different things, but is it in the integration that you have with the hardware, the robotics vendors themselves, or is it with the core software engine? It's probably all of that, but where do you think the deepest sort of competitive?
Oh, it's definitely on the software optimization and the ability to combine all sorts of different neural networks together and getting the best results out of them. That's I think the key of the keys.
Just following up on that question, why can't these robot makers themselves do the software, right? Why can't each developer, each robotic supplier have a software layer on top? What do you bring to the table? Like, if it is a particular application and there is one single robot there, the manufacturer can use the same software provided by the Japanese supplier.
Let me understand your question correctly. So you're saying, why can this robots company do it by themselves? Why do they have to count on a third-party supplier like
a
us?
hardware supplier, can do a software as well, right?
Well, I guess this robot companies are really good in doing mechanical stuff, right? Coming out with a very reliable, fast robots. That's their traditional strength. But when it comes to making these robots very intelligent with a lot of the software, that's not necessarily their strength. In terms of able to put together all the neural networks together, optimizing the software. I would say that's why you see a lot of startups these days are focusing on making robots more intelligent, and most of the startups are based in the U.S. and focusing more on software. And we actually see not too often, great software coming from robot companies in terms of the vision product.
Taiwan hasn't been very good at software either. Right?
There's an exception to everything. Yeah.
Thank you, great presentation. If we were going to try to do what analysts do, which is calculate a TAM and try to impugn some growth rates, some of this sounds pretty interesting. Can you give us some help on, what the TAM looks like, what the growth rates for you as you penetrate that TAM look like over the next 5 years, say?
That's a very difficult question, because I can give you a rough answer to that. Right now, on the robotics side, as you can see, we have solutions for robotics and non-robotics applications. Let me just say for robotics, okay, each year, right now, there's about 500,000 units of robots sold. If you think about electronics or car industries, this is not a big industry, 500,000 units sold per year. Okay, so the growth rate in the last few years is up and down. But we do believe that having smarter software would help to generate more applications for these robots. So we do believe that the growth rate of vision will be computer vision or AI vision will outpace that of robots, itself. Yeah. How fast that growth is, it really depends. For small companies like ours, we are able to double, triple that growth rate. But for machine makers, machine vision makers who are focused on traditional type of machine vision, that growth rate will be a little bit slower, because we're talking about, those kind of things has been around for 20, 30 years already, traditional vision, yeah.
Can you take what you're doing here and expand it into different markets? Because some of it sounds pretty interesting if you're able to do what you're doing without a lot of resources. In other words, if you could bring that to other applications and expand it and still keep the efficiency with which you're able to apply AI to different applications in different markets, I mean, that could be, you could expand your applications without a ton of capital investment and grow really fast into a big TAM. Is that what you're looking at, or maybe you could help us out a little bit?
Thank you. Yeah, that's a great question. In fact, we are doing that. Like I said, originally we were focusing on robots, defect inspection. Those are really realms of manufacturing, mostly in some logistics. But the last section I talked about what we did with AR and AI, right? Combining augmented reality and AI. And then we started to see a lot of different applications outside of traditional manufacturing. Retail, I showed a couple of retail, there's actually a lot more real retail applications coming in. Agriculture, some of them, that's not big, but, and also transportation as well. We are also seeing quite a bit of transportation. So for example, we are also doing this inspection work for subway systems in one of the Southeast Asian countries, the cities. Yeah. So we are, like I said, we are applying this to more and more sectors outside of manufacturing. Yeah. And we see, particularly retail, there's a lot of opportunities there. Yeah.
Thank you.
Hi, thank you. Can you talk a little bit more on your short-term financial numbers, given that you say that the automation business, the vision business will grow rapidly, given you have a smaller size. It seems like this vision business decline year over year this year. Can you talk a little bit more on how this situation goes right now?
I don't know where the number is coming from. The vision business is actually this year so far is more than double year on year. I think what you're referring to is automation as a whole. Automation will include our the distribution of Rockwell automation products. That is still a pretty significant chunk of our business. Yeah. So as a whole, this year is not a good year for us, especially for our older lines of business. Like for gensets, for generators, the business we have in China is declining actually quite fast, because we are distributors of U.S. branded products, and I think that has been, we have not done well in China for those products this year.
So what's the exact sales contribution for your vision business?
Right now, it's not high. It's still not double digit yet. Yeah.
Okay, thank you.
Thank you for the presentation. I guess your strength is a low cost, very fast, very optimized, using very little training samples. But as the models get better and better, or bigger and bigger, does that affect your long-term outlook? Or How would that change your business model? Thank you.
Let me understand your question. You're saying basically you're saying if when the models are getting better, you mean the open source models, right?
Yeah.
Okay. Yeah. So that's why we have two elements I talk about. One is optimization of the neural networks, and the second one is putting a lot of different neural networks together. From experience, I can say that's a very important part of the equation. The ability to combine two or even more seemingly unrelated neural networks together, and getting them to be adapted to a wide variety of applications.
Can you comment a little bit about the competitive landscape for machine vision? I mean, in Taiwan, I think you guys are the only player, at least that I know of. But if you look broader across the region, across the globe, who are the other companies that are major players in this space?
Okay. I introduced, broadly speaking, three different products: robotic vision, AI defect inspection, and AI plus AR. Right. So, three different lines of product. For robotics, we do have quite a few, to be honest. You have a robot maker like Fanuc is making 3D vision for robotics. You do have some U.S. startups that's competing. For example, those MIT, PhD guys starting, or Berkeley PhD guys starting. There's probably at least 10, 11 globally, kind of competent suppliers on the robotic 3D vision side. Okay. Again, the strengths of each differs. Some of them are stronger in logistics application. Some of them are more focused on manufacturing applications. Okay. For AI defect inspection, there are quite a few, but again, it really depends. It's kind of hard to say who are competent competitors there. But in general, I would say the one that stands out is Cognex in the U.S. Keyence is a very big player, but Keyence has traditionally focused more on traditional type of machine vision rather than AI. Yeah. I think Cognex has acquired a couple pretty good ones. One in Switzerland, VD. That's how they got their AI product. And then they also bought another Korean company called Swirl. So the only well-known one is Cognex, and also a German company called MV Tech, which makes Halcon software. So if you ask me, these are the two I can think of right now. As far as the last product, the combination of AI and AR, so far there is no real, it's so new, there is not any real competitor in this market space yet. Yeah.
So I think we have time for one final question. Okay, if not, we will wrap up here. Thank you everyone for joining us today. Thank you.